All right, guys, now we're going to talk about graphing rational functions. So you just learned how to identify the transformations and asymptotes. So to graph them, all we're going to do is sketch both things on a graph and use your parent function as a guide. So just to remember, our parent function looks like this. So it's a little whoop whoop, right? So look at an example 1. It tells us to identify the transformations. So our first one we're going to say is right 3 and then up 2. And then our horizontal and vertical asymptotes. So remember, horizontal asymptotes comes from our up and down. So we're going to say horizontal is y equals 2. And then our vertical, we set the denominator equal to 0. So we have our vertical is x equals 3. Now, all we do is graph these, and then you have your graph. So what I'm going to do first is I'm going to sketch my asymptotes. So at y equals 2, I'm going to draw a dotted line. So I'm going to go y equals 2 and draw a horizontal line at y equals 2. And then I'm going to do the same thing for x equals 3. And I'm going to draw a vertical line at x equals 3. This will give me kind of like so our parent functions asymptotes are our x and y axis. So when we draw our asymptotes, we're going to kind of think of those as our x and y axis guide. All right. So then we're going to, this isn't reflected or anything, so it's going to look the same as our parent function. So we're going to use the asymptote as our guide. So get as close to those two asymptotes as you can without touching them. And the green that I just did, and I'm going to highlight right here, this is our final graph. Okay? You can also go to Desmos and check yourself if you are unsure. Desmos won't show you the dotted lines as your asymptotes, but it will have them as a guide. Okay? So let's look at example 2. So this one, we have a reflect over x. We have a left 1. And we have a down 3. So then our horizontal and vertical asymptotes. Remember, our horizontal asymptotes comes from our plus or minus on the outside. So we're going to say y equals -3. And then our vertical asymptotes comes from the denominator. So x equals -1. So I want you to pause and try to figure this out and see if you come up with the correct graph. Okay, so when we graph this, I'm going to first sketch my asymptotes. So I'm going to say y equals -3, and I'm going to draw a horizontal line. Then I'm going to say x equals -1, draw a vertical dotted line. And then this one reflects. So what we're going to do is first, when we reflect, we're going to flip it. So instead of starting down in this quadrant, when we reflect, we start in the top quadrant. So we're going to start up here. And then when you shift, which I didn't write down, so I hope you caught that. So our vertical, we also have a vertical stretch by 2. Okay, when you stretch a function, it goes away from where it crosses, your asymptotes cross. So it kind of stretches it out into more away from the middle of your graph. So if you notice here, these 2 points right here are kind of close together. When you stretch, they stretch further apart. Okay? So that is what our graph looks like for this function. So it reflects, so it starts up here and down here, And then we used our asymptotes and our reflection to sketch it out. All right. Let's do one more together. So let's write our transformations. This one reflects over x. And this one we need to rewrite. So we need to take our GCF of 2 out on the bottom. When we do that, we're left with x plus 3. So that means we have a vertical compress by 1/2, and we go left 3. So if you notice, we did not go up or down at all. So that means our horizontal asymptote is just y equals 0 because we didn't add or subtract anything away from our fraction. Then our vertical asymptote, we're going to take this x plus 3, set it equal to 0, and get negative 3. So our vertical asymptote is x equals negative 3. So let's sketch this out. So first I'm going to draw my asymptotes. So y equals 0 is our x-axis basically, and x equals negative 3. So those are our guidelines. So we reflect, so our graph is going to look start in the same spots as our example 2 did, but this one we are going to compress. So if you think back to example 2 when we stretched, it went away from where the asymptotes intersected, right? When we compress, we get closer to where they intersect. So I'm going to start here and get as close to that intersection point as I can. Keeping in mind that we are reflecting, so we have to start in the top instead of the bottom. So that is what our graph will look like. All right, pause the video, try example 4 on your own, and then unpause and we'll go over it. So for this one, we are going to reflect over x. We have a vertical stretch by 2. We're going to go right 3 and up 1. Those are our transformations. So when we write our horizontal asymptote, we have our horizontal asymptote as y equals 1. And our vertical asymptote is x equals 3. So when we sketch this one, we have y equals 1, x equals 3. Whoops. And then we have to reflect and stretch. So that means we're going to start in our top quadrant and stretch away from our intersection. So it's kind of going to go like that and like that. All right. Have a great day. Thank you.